Alright guys, here we are with our polynomials review. So we are going to find the roots. Now remember, the roots also are the x-intercepts, the zeros. Those are other names for those, okay? So now it says do not give it decimal answers. That's fine by me, because we want to use our technology to help us with this, okay? That's essentially what we would like to do with this stuff, okay? So, using the technology, okay, we've got two options. Okay, the first is using our calculators. So, looking at our calculator, right, we can open up a graph, type in our graph just like question 1, okay, and then hit enter and we see our graph here. We can mess around with the window if we want to, but since we're looking for roots, zeros, x-intercepts, we can hit menu, go down to analyze graph, click on 0, click on one side of the first 0, scroll to the right and click, and then we answer them. And we just repeat that same process for each one of these intersection points, okay? And things look great, okay? And we're happy with that. Okay, now, so that would be our answer for question number 1. We would type in, or write in our answers, just like that. You could even write just x equals -4, -1, 3. Either way works. Okay. Now, if you don't like using the calculators and prefer Desmos, we can do the same thing with Desmos, right? So like take that for example. Go to desmos.com or the app, type that in, and then see where it crosses. And in Desmos, we type it in right over here. Okay, and then we just click on our points, and there's our answers for question number 2. Okay, and this works pretty great. Much easier than trying to do it by hand. Okay, now one thing to remember is that the degree of your polynomial tells you how many zeros there should be. Okay, and here's where we run into issues with graphing. Let's take a look at number 5. Okay, so I type it into my calculator and I get this, and I do all my work and I say, oh great, 3 and -3, those are my answers. But here's where we run into a problem, okay, because look at our degree, it's 4. We should have 2 more here. Okay, so what that means is we've got some imaginary, also known as complex numbers. We've got something I, okay, remember that square root of -1 being imaginary number? Okay, we've got to deal with that. So there is a better way using our calculator that we can help with that, okay? So here's a better way to do it. Okay, so we go to a calculate screen, hit menu, go down to algebra. Okay, from algebra you click on Polynomial Tools. It's not number, it looks like it is, but it's actually algebra. Polynomial Tools. Do find roots of polynomials. Okay, then you've got to tell us the degree, and you can choose from real or complex. Always click here and turn it to complex, because complex will tell you the real roots plus the complex ones. Works much better. Then you'll see this pop up, and you put all the coefficients in. Okay, so like the example we're using is that, for example, x cubed plus 2x squared minus 11x minus 12. Okay, so it'd be 1, so I type in a 1 there, then 2, so type in a 2, don't type in the x's, then -11 for here, and -12 for here. Then I hit OK, and then it'll give me this list. Then I hit enter, and there's my answers. Okay, which correspond with what we found here with our graph. Okay, so I keep doing that. So here's number 2, I typed it in the same way. There's our answers. Then number 3. Okay, there's our answers. Now these are the decimals they didn't want you to deal with, but -1.4, -1, and +1.4. Okay, and number 4, same idea. -3, -2, and 1. Or in other words, -3, 0, -2, 0, and 1, 0. plus this helps us with this situation, okay? So I go to that one, and it was what? X to the 4th minus 5x squared minus 36. Okay, now notice we have 1, 2, 3, 4, 5 spots, but only 1, 2, 3 terms. That's because it's really x to the 4th plus 0x cubed minus 5x squared plus 0x minus 36. So anytime you have missing terms, you assign their value, their coefficient as 0. So I type those in, and then I hit OK. And then we end up with this one right here. So this is number 5. Okay. So see my answers, negative 3 and positive 3, which we found graphically, but negative 2i, so negative 2i comma 0, and 2i comma 0. Okay, so it's got those imaginaries, but using this trick with the calculator, and I guess it's not a trick, it's just using our technology, we can do it. So number 6, okay, we get those. Notice it's a cubic, and we get our information. Okay, number 7, right here. It's another cubic, so we get 1, 2, 3, but they're imaginary. And then finally, number 8, there's 4 of them, so we get those 4 roots. And that's how we can do it graphically or non-graphically, which honestly I think with the calculator that non-graphically is a lot better. Okay? Now once again, just to compare, okay, looking at this, here's number 8 graphically. Okay, and we only see those 2 real roots. Because of its nature, it's got those other 2 imaginary roots that we can only find by using this. Okay? Alright, there we go with those ones. Now, number 9 and 10 want us to describe the end behavior of each function. So remember, end behavior is as x approaches positive infinity, meaning graphically as we go to the right, f of x does what? Goes up, goes down, approaches a number. And as we go left, as x approaches negative infinity, f of x does what? Okay. Now there's another way to write it. You can write the limit as x approaches positive or negative infinity of f of x equals. But I think this way is a little easier for us to do. So let's graph these and look at it graphically. So if I'm looking here at number 9, this is what we get. So as I go to the right, which direction are we going? We're going to keep going up to positive infinity. So over here I put positive infinity. As we are going to the left, as we go this way, it's going down, so we're going to negative infinity. So we put negative infinity here. Okay? And that's something, as we get to number 11, that we want to remember about odd degree polynomials. Remember, for odd degrees, so that's 1, 3, 5, 7, and so on, okay, if it's a positive coefficient, the number in front of the highest degree, right, positive, it looks like this. As we go to the right, it goes up. As we go to the left, it goes down. For negative, it's the opposite. As we go to the right, we go down. As we go to the left, we go up. So if we look at this one, it says we have a third degree polynomial, positive, so this guy, a 0 at 4, so we know that the x-axis we have a point. Now a maximum at negative 1 and a minimum of 2. So a maximum is it's going up and then back down. Minimum down, so minimum, maximum. Now they could be local and it could keep going up or keep going down, but that's the main idea we want to do here. So I know my end behavior, I'm going to start going off here somewhere, okay? And so I know at negative 2 or negative 1, so this line, I should be hitting a maximum. So I'll go come up, hit a maximum, then go back down. Then at 2, I'm hitting a minimum, so then I go back up through my line, and my end behavior keeps going up. So your graph may not look exactly like that, but it's the same idea. Okay? Okay, now let's look at number 10. Okay? So number 10, let's graph that one. We get this. Okay. So as I go to the right, where are we going? Down. As I go to the left, where are we going? Down. Okay, so they're both down to negative infinity. And with even degrees, here's what we get. So like 12 wants us to do a 4th degree polynomial. So it's even. With even, the rule is, so that's 2, 4, 6, 8, so on. Okay, the rule is you have positive coefficient and you have negative coefficient. For positive coefficient, they are both going up. For negative, like what we saw here, they're both going down. Okay, so a 4th degree polynomial has a 0 at negative 4, so 0 right there, a maximum at 2, and a minimum at negative 1. Okay, now, so a maximum at 2 and a minimum at negative 1. So, and they're usually kind of symmetrical. Now, it doesn't tell me if it's positive or negative, so there's two options here. My first option would be it's coming down. We totally missed that. We hit that, and then at negative 1, I pop up, and at 2, I pop back down. But see, then I'm going to have to pop back up again, so it's not giving us all the zeros. So it either look like that, or it could honestly look like this. And go down that way. Kind of like an M or a W, either one of those. But here's the basics for that. Okay? And we already got those ones. Alright. So this last one, it says 13. The amount of a certain chemical in the soil T hours after a chemical spill is given by the equation. And those X's should all be T's. It should really be written like this. Negative, T cubed plus 4T squared plus 4T plus 5. Okay. How long will it take for the chemical to dissipate? So these T's stand for the time. The A of T stands for the chemicals. So to have all the chemicals gone, A of T would be 0. Okay, so essentially what we're looking for here is where does our graph cross the x-axis? Where is it 0? So I could try to figure this out by factoring and doing that, but once again, let's graph it. So here's our graph. Okay, there's the x-axis, there's our y-axis. Okay, so our y-intercept is right there, which tells us when we start timing, we have 5 whatevers, I don't know how particles per billion, whatever you want to call it, of the chemical in the soil. Okay, then there's more and more chemical till about 3 minutes, days, years, I don't know what the X stands for. There's 26 of whatever in the soil. Then it starts to decay until we get to 5, I don't know, seconds, minutes, days, hours, years. Doesn't really tell us, but there's our answer. Okay, so T would equal 5. Oh, hours. So in 5 hours, it'll be all gone. So at 0 hours, we had 5, and it doesn't say how much of it. 5 of whatever's parts per million or parts per billion. That's usually the measurement they take about that kind of hazardous stuff. At a little over 3 hours, we hit our maximum amount of particles in there, and then at 5 hours, it's all gone. So there's our answer. Alright guys, so that's pretty much it for the polynomials. A little bit of knowledge, a lot of usage of technology, but you got to know how to use the technology to help you out with that. And there we go.